All right, our first lesson here, I would normally do this in person, but we're going to use what we have. So I'm going to talk about measuring, and we're still at the beginning of the chapter, still at the beginning of the course. There's going to be a lot of vocabulary. I'm also going to talk to you about how to use some of the tools that we have to make some constructions and do some measuring. I'm going to change the screen. I'm going to get rid of my face so you don't have to look at me, and you'll be able to see more of the screen. There we go. Okay, so I'm measuring up. A little bit of vocabulary, the anatomy of an angle. So we're kind of digging into angles here. With this angle, there are vertex. The vertex is where two rays come together, and they have a common endpoint or beginning. And you can kind of see that this ray here, BA, goes off indefinitely, and this ray here, BC, goes off indefinitely. So you have two rays that have a common point, a common endpoint or beginning, and that is called the vertex of the angle. There are sides of the angle, which is BA and BC, two rays. And then we have the inside of or the interior of the angle is between those two sides, and the exterior of the angle would be outside of those two sides. There's a couple ways that we can name this angle. We can talk about this angle. One way to talk about it is by naming all 3 points, angle A, B, C. B always need the vertex. I should say the vertex always needs to be the center letter. You can see that right here, angle ABC. So B is the vertex. It's always, or B isn't always the vertex, but in this picture, B is the vertex. The vertex is always the second letter. You can just call it by the vertex, angle B. The challenge with that is if there was another ray, BD, going off in this direction, this way, now we'd have to be more specific. We couldn't just say angle B, because that could be 3 different angles that we're talking about. This particular angle is not 1 degree, but it's labeled 1. So we could also call it angle 1. And sometimes we do that, especially if there's lots of angles at angle B. I might call this angle 1. And then if there was another ray shooting off, I call that angle 2. And so that's another way to name this angle. So lots of ways to name it, but that's kind of the anatomy of that angle. So when we talk about the vertex of the angle, and when we name those angles, those are a couple ways to do it. Adjacent angles. So adjacent angles, we've got this picture here. Adjacent means right next to. So adjacent angles would be right next to each other. When I'm teaching, especially with these vocabulary terms that are really fresh or new, I often try to find some kind of a hook for students. So I'm talking to you as an educator now. If I were going to be introducing this to students for the first time, this term adjacent angles, I might talk about the classroom next door and say, the teacher right next door, her classroom is adjacent to mine. We have a wall that we share. So right on the other side of that wall is another classroom. Trying to find a connection that students already are familiar with. They're familiar with the idea of 2 classrooms being right next to each other. And they're familiar with sharing a wall, because you can knock on the wall and have the other teacher knock back, or a room, a bedroom, or whatever. So adjacent angles are angles that are right next to each other, and they share a wall. They share a common side, in this case, side PR, or ray PR. It does say that they share a common vertex and a common side, but without overlapping interiors. I wanted to give you a visual. I mentioned this in an earlier video about the vocabulary, but we are visual learners. Whether you admit it or not, having a pictorial image of what we're talking about is really, really helpful. It makes things go a lot faster when we're talking about shapes, when we're talking about numbers. So here are 2 rays, this one and I don't know, this one right here. They share a common vertex. We got this angle, we got this angle, but they're not adjacent. They do share a common vertex, not adjacent to each other, because they don't share a common side. They don't share a common ray. They don't have a wall in common. So that, not adjacent. I draw a similar picture to the one that was on the screen before, we definitely have a common vertex here. But I'm going to talk about this angle and this angle. So this angle right here, smaller one, and then the whole thing. These two angles do share a common vertex. They do share a common side. They do have a wall in common, but they're not adjacent because their interiors overlap. I can't give you a good example of that in a physical classroom context. My analogy of the classroom falls apart here, but this would be not adjacent. Even though it technically has a common side and has a common vertex, their interiors overlap. And so that's why that piece is in the definition. All right, going back. Now that I've done that, I think I'm going to have to go back to my document camera here in a second too. Yes, measuring a line segment. Okay, so I'm going to go back to my document camera. I'm going to talk about a ruler and just make sure everybody is familiar with using a ruler and how you measure things and all that. If you've got this, you can maybe fast forward. I don't know. Here we go. Don't fast forward. Okay. I'm just going to quickly go through this, and you should be able to see with this camera. If I'm going to measure this line A, not B, not C, but A, well, I'll measure all three. I could use inches. So I got the inches side of my ruler here. Looks like A is about 1 inch. Looks like B is about a ½ inch. So it's halfway from 0 to 1. And it looks like C, C is a little bit different. C isn't a nice half or whole number. So half would be right here. 1/2 is also 2/4. So there's 1/4, there's 2/4. The next smallest line is fourths. 1/2 is also 4/8. The next smallest line would be an eighth. So you have 1/8, 2/8, 3/8, 4/8. There'd be 5/8, but it's a little beyond that. So the next smallest line down will be a 16th. Half of 8 is 16. This would be 8/16. 1, 2, 3, 4, 5, 6, 7, 8/16. 9, 10, 11/16. So it looks like this was 1 inch, this was 1/2 of an inch, and this was 11/16 of an inch. And this sheet here that you're not going to see, I asked you to do some multiplying and some adding of subtracting of different sides together. And with fractions, that can be a little more complicated. There's just a little more to work with. You need to get common denominators and do all this other stuff. Thank goodness for the metric system. Metric system is set up with decimals. A metric system isn't set up in base 10, where you have, isn't set up in base 12 like inches. Inches are set up in base 12, 12 inches in a foot, and then fractions from there. In metrics, we've got base 10. So if I was going to measure this in centimeters, I would say it's 1, 2 centimeters. I know it says millimeters here, mm, but that's every tiny little dot or dash. So you got 2 centimeters and then a little bit more, and each millimeter is like a decimal of a centimeter, 0.1. So you got 0.5, 0.6. So that would be 2.6 centimeters. This one appears to be about 1.4 centimeters. And this is not a perfect, precise ruler, and I don't expect yours to be perfect and precise. So if you said 1.1 instead of the 1.2 I see, if you said 1.3, yeah, you're pretty close. You know how to do it. You know how to read a ruler. So I'm going to be less concerned about perfect preciseness because these are not perfect, precise tools. But if you said 5, that would be wrong. You got to be pretty close. Okay, so that's, using a ruler. We've got metrics. If you're going to use a calculator with students, I would recommend metrics. Calculators are decimal, metrics are decimal. If you really want to work on fractions, because that's your unit, that's what you're working on. Oh, all the fractions here. Wonderful stuff. And that's using a ruler. I also want to talk about measuring an angle. Again, I've got a sheet that you are not going to see. This is just an example that I'm going to use. And you were asked to have, along with a ruler, you were asked to have a protractor. Got a couple here. This is kind of a standard style one. This is also a fairly standard one. And I'm going to show you how to use a protractor in case you forgot. I'm going to use this one to start with, but I'll mention this one too. They work the same, but this one's a little smaller. And when you're measuring an angle, I should start with saying when you're measuring an angle, we're measuring in degrees or radians. A protractor measures in degrees. I'm not going to really get into radians right now, but make sure that if you're using a calculator, which I don't think you'll need to, you have your calculator set to degrees and not radians if you're using a protractor. So protractors are measured in degrees due to trigonometry and some other stuff. When we measure degrees, we start typically we start in going in the bottom right direction here, and we move counterclockwise to the left that way. That's how we measure angles, and there's reasons behind that we're not going to get into. We're going to line up our protractor on the vertex. So there's the vertex. The vertex should go right here in the middle of your protractor. Some of them have little dots there with a kind of a T, so you can line it up. Some of them do not. This one has that dot a little bit, but it's kind of a big dot, so I have to be a little more careful. The other thing you should not do, don't line this bottom line up on the bottom of your protractor. Most protractors, that's not where 0 is. The 0 line is right there. So that 0 line should line up right on the bottom line of your angle. And I'm going to move it over here until, there you go, until this line, this 90-degree line, and the 0 line come to a T. So they should both be pointing right at the dot. That's about right. I'm going to try and measure this now. I'm going to try and do this without moving too much. I'm going to measure here, and I'm going, again, counterclockwise. So I'm starting at 0, not at 180. I'm going to go 10, 20, 30, 40, 50, 60 degrees. It's somewhere between 50 and 60. I'm not going to do 120 degrees, 130 degrees, because I haven't gone that far. So I'm starting at 0. I'm going left counterclockwise, and I'm almost to 60, but not quite. And it's hard to tell. This is such a small line. If that occurs, and on a test or on a worksheet, you can't read where it goes. It's not big enough. You can always extend the line out. So I'm going to use the straight edge part of my protractor, and I'm going to extend it. Now I have a longer line. I'm going to line it up again on the 0 line, not the bottom. And I'm going to get that 90-degree and the 0 to come to a T. Now I can see where it is. It's right about there. I don't know how well you can see it through the camera, but it's at 50, 55, 56, it's about 57 degrees. Each little tick here is 1 degree, excuse me, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each little tick is 1 degree, and that's pretty standard. I could do the same thing. I'm not going to measure all these. You do the same thing with this. Line it up right. Again, here's that 0 line, not the bottom. And there's my 90-degree line there. And this one, well, okay, this might be a slightly more accurate. Nope, 57. There we go. I just didn't have it lined up right. 55 to 67. So same general idea. And you can measure all these. This one's looked to be about 90 degrees. Yep, 90 degrees. And so on. It might go past 90. That's okay. Just keep on going. 90, 100, 110, 120, and so on. So that's how you set up, line up a protractor and measure that angle. You will be asked to physically measure a line or an angle on the test. And in future chapters, we will be doing construction. You will be constructing figures. So you need to be able to use a compass, excuse me, not a compass, a protractor and a ruler. All right, going back to the lesson. This is going to be a long lesson. In fact, I'm going to stop there. I take that back. I'm gonna stop here with this. I'm gonna make a second video for the second half of this.